We're going to continue today with transformations, and we are going to look at reflections. So reflecting letters for printing. When you look at a rubber stamp, in order for the letters and the numbers to appear correctly on the paper, they must be etched as a mirror image on the rubber pad. I want you to print out all the letters of the alphabet in lowercase. Think about what they would look like if they were written as a mirror image. Make a list of which letters would look the same whether they were written forward or as a mirror image, and which one would look different. The ones that look the same in uppercase, sorry, you should do these in uppercase, are A, H, I, M, O, T, U, V, W, X, and Y. Do lowercase look the same written forward or backwards? Well, that would depend on the font that you use. Some would be vertically symmetrical, I, L, O, T, V, W, and X. Do any uppercase letters look the same whether they're reflected over the horizontal line of symmetry? Now we're talking vertical here, so if A is reflected vertically, it still looks like A. Now, what about if the line goes horizontally? Well, some uppercases look the same. B would, if it was reflected that over the horizontal line, it would still look like a B. C, D, E, H, I, K, O, and X. So if I took K and reflected it horizontally, it would still look like a K. So would an H, so would an E. So just something to think about. It helps you to understand what is happening with a reflection. Okay, Colin owns and operates his own printing business in Port Coquitlam in British Columbia. He is printing a window decal for students, and the sticky side is on the front of the decal so that when you stick it to the inside of the window, but you read the sticker from the outside. So the design on the sticker is printed on the non-sticky side. So Colin needs to create a mirror image of what the sticker is supposed to look like. So across which line of symmetry would Colin reflect the image in order to create the reflection that it would allow him to print the design and reverse the lettering? So are we going to reflect it over this line? So it would look similar to this. Or are we going to reflect it over this line, which then would make it look like, kind of like this. Okay, which way should we put it? Well, the correct answer is over the y-axis, so we're going to reflect it here, not this way, otherwise it'd be upside down. So the y-axis. Okay, now we have to look at each vertice. So C is 1 and 2. Now, I want the next C to be exactly the same distance away. So C is 1 square away from Y, so it needs to be on the other square, exactly the same distance. So it's going to be -1 and 2. And that's going to be C prime. Okay? Let's take a look at A. A is 3 and 1. And so A prime is going to be -3 and 1. So reflections across the y-axis, the coordinates are actually going to be the same, but you'll notice that the y coordinates stay the same, but the x coordinate becomes negative. So y's stays the same. And the x's become negative. right. Here's all the coordinates for the reflection of the tree, if you want to check your answers. All right, how many lines of symmetry do the following shapes have? Well, what that means is, can you create the same shape by reflecting it over a different line? So we have a rectangle. How many ways can you actually reflect that shape to create the same one? Well, we could go horizontally and we can go vertically. So a rectangle has 2. Pentagon, a regular pentagon, has 5 sides. Whoops, if you draw it properly. And if it was exactly drawn evenly, it would have 5 reflections. So the left and the right, if we folded it on the line of symmetry, you would create the other side. So if we cut this out and fold it in half, you could fold it right on that line of symmetry. We could fold it on this one, 2, 3, 4, and 5. Pentagon would have 5. A rhombus. Rhombus looks like that. Okay. It would actually have 2 through that fold and through this fold. So this is C rhombus. And that would have 2. A kite. A kite actually only has 1 just through the center. And an equilateral triangle has 3. So you'll notice that if it has 5 sides and it's a regular pentagon, that means all the 5 sides are the same. It will have 5 lines of symmetry. Rectangle, because all the sides are not the same, you only have 2 lines of symmetry. A square will have 4 equal sides, 4 lines of symmetry. Oops, that was not very straight. An equilateral triangle, 3 equal sides, 3 lines of symmetry. So build your skills, page 225, 230, questions 5 to 12.